So this is where we left off last time. We integrated STB TrueType to load in fonts and place them into our own font texture format. And we also worked on software rendering so that we can place glyphs from the texture at the screen like so. Right now we render at 80 frames per second because it has to basically fill out all this screen with software rendering. Also, it's a debug release. But also we have our text editing functionality that we did in the first stream. So we can say something like, hello stream. I cannot delete, so I misspelled. We have a deletion bug, and I will soon fix that today. Happy New Year, if I could say so. Also, we can navigate with the cursor errors and place some new characters where the cursor's at. Sadly, the only thing we cannot do is properly delete because I messed that up, but we're gonna fix that today. So. But first things first, I want to copy the state from last time and just like in HeadMade Hero, advance 1 day, go into that folder instead and see if that works. So you can see everything is empty. Oh no, nothing. Let's just, for curiosity, just rebuild everything so that we see that I'm not cheating. This is live. So this is where we are, and then we can, I will start my own editor, which is probably something I didn't link. Did I link it? I did link it. Wow. Okay. I'm gonna reduce the font. I'm gonna make it full screen like so. People hate the line wrapping, so I'm gonna disable the line wrapping. Well, yeah. Anyway, occasionally I will enable it. So, and then we go into the to-dos that I had set up for this day and just go over this. So last time I was wondering why the _debug command wouldn't work. Just because if we look at our build .bat, I was assuming that specifying /debug would also give us this debug environment preprocessor directive, but I had to do it manually like so that we get the debug without an underscore. Turns out that if you use the debug C++ or C runtime, this variable will be set. So if we would use the mtd /mtd instead of whatever basically Visual Studio decides to use, we should be using the statically linked C runtime with debug information. This is the one without debug information, and there's also the threaded one, the DLL one, which is MD. But we can just, as usual, it's tradition in our stream to Google those flags. So if we look for CLMT flag, it actually found it. Wow. So you can see this informations and this. Oh, I should turn this in English for you guys. So you can see this information that tells you what this directives does. We are interested in this /mt one because this uses the static version, which means that the static library will be linked into our program, which also means you don't have your users to download the respective distributions. Oh, I'm famous. Thank you, Samuel. Totally famous. So basically, if you use the static version, you don't have to worry about people, well, for the most part, worrying about people having to download the latest or the Visual Studio distributable that you were using. Like if you use the dynamic one, which is the MD one, it requires the specific DLLs to be present in your system. So in order for users to run your application, they would have to install the redistributables, which we all love. But if we just use the static version, we can just link with them, and there's no harm in that. Also, there's the debug version, and as it says here, it will define the _debug variable for us. And this will allow us to do better debugging in our code. And that's what I'm going to use right now. So E. Then we do no longer need to define our own debug symbol, but we will have to replace our assert code to use the new symbol. So let's search for debug and replace it. Oh, we have a debug. Oh yeah. Yeah, we need to replace it with underscore debug because that's the internal variable Visual Studio will, the compiler will define for us when we use the MDD flag. So that's all in this file. Then we have our font. Do we have a debug in here? Don't have any debugs in here. My editor is not capable of replacing in multiple files at once, but that's usually not a problem for me. This has also no debug. Has no debug. So it was basically just our assert. So let's just see if that actually worked. And in order to check that, we go into our main, and we're just gonna assert before we do anything. And if that triggers, then everything was set up properly. So we compile. Welcome, Ray Artificer. I always pronounce your name wrong. So it crashed at the proper location, so that means we set up the assert properly. So now let's see if everything works. Yeah, everything still works fine. And now the next point in our to-do was to check line spacing. Well, I'm not too sure about the line spacing part. I'm gonna leave that for later. I want to fix delete. So in order to do so, we want to debug our application and see why it's failed. So if you if you're on the Visual Studio command prompt, you can use the call to devenv and then specify an executable you want to debug, preferably with debug information. Then you can launch Visual Studio and it will set up a debugging project for you. So it has no source files or anything associated with it, but you can step through the program. Artificer. No, not now, maybe later. Okay, I really hate it that I have to set this up for every account on the computer. It's just a streaming account. So, and it will set up this project. It has not too many settings. In our case, it will tell you which exe is going to be run. You can specify arguments if you have any, and you can specify where the working directory is. In our case, it's just where the exe is, because that's what the exe expects. And then you can just hit start, and it will run your program. And I typically just break somewhere, and it will open some files for you. So you don't have to search for the source file manually. You basically can use the break feature and it will open the proper source file, and then you can look up other files and break and see what's going on. So in our case, we're interested in what happens when we delete stuff. So our code for deleting is here. When we read the backspace character. Oh, we just decrease the text count. Is that correct? Doesn't make any sense to me. I thought we did more than that. Is this all the deletion code we do? Let me think about it. I mean, it should be all, but this does not update the cursor position. Like basically, since we also have to decrease the cursor. Also, it does not take into account that our cursor might be at a different location. So I'm not quite sure what I was thinking with this code, but let's open the appropriate editing file. I don't know where I placed it. Was it all in this file? We had a very lax structure. Yeah, here we have the remove thing. Do we ever call this? So this font is a little bit small maybe for the stream. So we have this remove, we have this remove. Is it ever called? Seems like we never called it, which suggests that might be the issue. So we basically just decremented the count, but now our cursor, well, we can test that basically. We'll just run again. And I type something in like, hello chat. Then I delete, and this should set the text count properly, but it will not set the cursor position properly, so that the cursor will be outside of the bounds of the text, and that should trigger an assert. Or set the text count to some enormously large number, which is not what I would have expected. So let's see. Should be here, like it should trigger this at this point if we hit delete. So let's just see. So delete. So we're here. We have a text, and it will just decrement the count. And then what will it do other than that? So, oh yeah, the cursor is out of bounds. So computations on where to place it will be probably messed up here somewhere. Like here. No? Here? Yeah, here. Okay. So yeah, not too big of an issue. We basically never updated the text cursor. Easy enough to fix, I think. So we have to find the proper place. Yeah, so backspace. What we want to do is call our remove function. I want to know what the interface for that was. We have the text, the cursor, and how much we want to remove. So that's pretty easy, right? Next, cursor, and we want to remove 1, but only if we have a text cursor that is greater than 0, basically. Otherwise, because we want to delete something in front of the cursor. I think that's it. So let's see. We compile. And hello, chat. Okay, that didn't work. See. Step through it. In this code. The search in Visual Studio is so annoying. Oh my god. So we already set the debug rate there, so that's good. Hello. So we have a text cursor. That's fine. And then we want to see. Oh yeah, it skips this. Text cursor needs to be bigger than remove count. Makes no sense to me. Should be the other way around. Or do I delete after the cursor? What was I thinking with this function? Text cursor plus remove. Yeah, so essentially, I think this function tries to delete whatever's after the cursor. So in order to fake that, we can do something like dummy cursor, set it to text cursor +1, so that text cursor -1, because we want to delete whatever is after the cursor. That's what the function expects. We will later fix this, so make it a little bit easier to use with an alternate function call, something like remove before or remove after. But right now I just want to see if it works at all. So, and after the dummy cursor was updated, we also need to restore whatever dummy cursor is. And yeah, we basically have to add 1 to it to know where our new cursor position is. I think probably completely messed it up, but hey, Hello, and let's see. But dummy cursor, it's 3. Also, this call doesn't make any sense whatsoever. Why should the remove count be relevant here? The cursor should not be bigger than the remove. Doesn't make any sense. I don't really know what I was thinking with that function. But as you just saw, I basically implemented it without ever using it. So we can only remove stuff if the cursor plus our remove count is less equal to text. So if our cursor is actually at the end of the text, cannot remove anything behind it. And do we have to check for anything else? So let's see. I mean, as long as there's room. So, and yeah, it should be enough to do this, I think. But hey, I messed it up so many times. So what's more? What's once more? Hello. Okay, that's obviously not correct. Let's just see what actually happens here. Hello. Weird thing is that Visual Studio wasn't able to set the breakpoint, so it basically just disabled debugging for a second there, but now it set it up again. So you want to delete character at position 3, I think. So now, I subtract this, so should be character as position 3 should be the cursor position already. So what was I thinking with this call? Everyone, back up. Just back up. I'm gonna back up this. I'm gonna do the normal implementation first and just say, hey, make this happen. So yeah, cannot type. So essentially, we can only remove things in front of the cursor, and that way it means that the remove count needs to be less or equal to the text cursor. Otherwise, we cannot delete anything in front of it. And we need to make sure that actually this is enough, right? This is enough. If there's room in front of the cursor enough to delete, then that should do the trick. But again, I keep messing up, so that's fine. I mean, it's a new year. I haven't touched this code base in over a month. My internet was down. So a little gif on Saint Nick to cut off my internet for 2 weeks or so. That was awesome. I probably have been a very, very bad boy. So we delete, but we do not properly mem copy here. So did I build properly? If building is so fast, you sometimes don't even notice that it happens. Just saying. Okay. Yeah, so let's just debug this again. We're here. We want to override the character in front of the cursor. That makes sense. With whatever character is at the cursor. And now how many do we want to copy? As text count minus cursor count. That makes sense. So how's our cursor text count is 6. Cursor count is 6. So this essentially states that we want to copy no characters at all, which is just not right. So we need to move, we need to take into account the remove count. Does that make any sense? No, it's the last one. How much do we want to remove? We want to remove 1. So it needs to be text count minus cursor count minus remove count, because that's where the destination is. In indexing, still stuff that I do mistakes quite often, especially in an interface like that where you just subtract some arbitrary pointers from another. Can get quite confusing. So if that's true, can this happen? Cursor minus. Yeah, I think that's true. Probably it's gonna bite me. Probably gonna bite me. So, hello. Oh, yeah. So immediately crashed. Not good. Not good. So glad it didn't wipe my hard drive. So the text cursor is where we text cursor -1. So it needs to be text cursor plus because yeah, I think because basically the index at which we place stuff is this one. It's a text cursor minus remove count, but since we're subtracting this index, we need to invert the sign of this subtraction here. Okay. Well, you can, if you stick around, but it's gonna take a while. We can talk about operator overloading on your issues you have, but right now I'm gonna stay on topic. Okay, this looks good. So oh yeah, we do not delete stuff at the end. Interesting. Interesting. So why is this messed up? Let's see. I want to delete the is. This looks good so far. It didn't really delete it because, oh no, it did because there's a new line here. Yeah. Hello. And then if I type something new, remains the same. So where did those two commas come from? They're not part of the string, but they're still getting displayed somehow. So, but the beautiful part, since we already have text rendering now, we can also render our internal variables with the same method, like we render the frames per second. So let's just add that so that we get some more feedback on the state of our buffer. Yeah, you're welcome. So let's see. I need to get back into this code base. Also, people probably prefer a wider screen. So yeah, sorry for this, guys. So let's see. Here's how we render FPS. It's a little bit convoluted, but not too bad if you ask me. So we can actually factor this out so that we can use it multiple times. All this. Just a very limited print. And for that we need our frame buffer. I don't remember the type of it. It probably was something like SR frame buffer for software render frame buffer. Or what it's called exactly. Take that. Could pass it by pointer, but we are not really we're not really changing any properties, but we're filling the buffer where it points to. So I'm gonna indicate that this buffer is going to change, even though we do not actually change any fields in the struct. If you recall, frame buffer looks like this. So it's just basically some kind of fat pointer. It's a two-dimensional pointer array. We're not going to change any of these values, so it would be perfectly valid to just pass it by value or const or whatever you like. But I want to indicate that we actually are going to modify the content of the frame buffer. And that's why I'm going to pass it by pointer to indicate to the caller that there's some manipulation going on onto the frame buffer. That's all. And then we want some text. So we have a good old, did I introduce C strings or something? Yeah, so I introduced the notion of a C string to be just a char pointer and to indicate to the rest of the code that this is a null terminated pointer. That's what we're going to use here. And that's going to be the format. And then we want to use the good old dot 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 notation, which means we have varying arguments, just like printf would use. And then we can just say something like, hey, I want to use, we now have to use sprintf with varying arguments. In order to do so, we can just look it up. Was vsprintf? Looks like this, and instead of passing dot dot dot, which we cannot replicate, we have to pass a VA list. In order to get that, we call this function here. We can just copy paste this for now. So basically, you have some argument list. This is a special type, and it's also a little bit platform defined. I just call it VA arguments typically. Then you have to initialize it and tell it when it starts. It basically starts after the format parameter of the function. Then we can use our vsprintf function with our, oh yeah, I called this buffer. So with our buffer, we specify the format again, and then we use the VA arguments list like so. This will call sprintf as if we would have passed these arguments into the after the format like we did earlier here. And since I'm a bad boy and this is a unsigned byte array, we have to cast it to char pointer, string or whatever. And this will, yeah, I mean, I'm never gonna use it, but we can. There's also a safe call to sprintf so that we can guarantee that we do not overwrite, do not exceed our buffer length. Just have to look it up because this notation here is just ass, but basically just specify the size of the buffer after you specify the buffer. And if you recall, you probably don't, but that's why I'm reciting it here. We have our cArrayCount function to determine the size of static array literals so that we don't have to somehow replicate this value. We can just say whatever the array count of buffer is and pass that here. This way, sprintf s will make sure that the bounds of the buffers are not exceeded. Yeah, I use auto all the time. It's just basically saves me a little bit of time of typing the same type multiple times. So essentially, now we have this print function. We convert whatever the output is into our string format, which basically has a pointer and a count, which is what our write function expects for writing into a frame buffer. Also, as you see, we need a font and a cursor. Just have to figure out what those formats were again. So let's look it up. Font is just loaded font, I think. So we also need a loaded font in order to print. And we need a cursor, which I also forget what that was. So let's see. Cursor. Cool. Don't I have it anywhere here? Yeah, I toss the word cursor around a little bit too often in this context because one thing is that the cursor indicates the position in the text that we want to edit. The other thing is that the cursor for our rendering purposes is a position on the screen where we're going to render the text. So yeah, so there's a text cursor and a font cursor basically, and this is how a font cursor looks like. And now you see that using auto also has its drawbacks because now I don't know what type it is and I have to look it up in here. It's just font cursor, how conveniently named. So let's see, we were here, we have a font, we have a font cursor, we have a format, And then we can just pass these values down. I don't remember if write expects the font to be yeah, so as you see, I violated this rule already because write takes in a frame buffer without a pointer, but I'm just gonna pass this by pointer now because I mean, this is not gonna change anyway. We just read from it, but we want to indicate that we actually manipulate the frame buffer. So I'm just gonna do a little quick little change here. Oh, it uses the blit function, which also assumes the same behavior, because I was consistently flawed. So, a giant little tangent. So frame buffer dot becomes now frame buffer arrow. So like this. Good to have a somewhat decent editor. Where's the blit function? But I had a blit somewhere. But yeah, called destination here. That's why I didn't find it. So destination dot destination arrow. So I'm probably messed up a lot of things. So I'm just gonna build and see where it leads me. And since I don't want to skip the beginning of the compilation, I'm going to use bar more to force it to stop after it filled all the screen so that I can see the first error message. It's at line 57, main, and probably true. So we have a loaded font. We don't need that. Oh, that was all the errors. I am a bit surprised, I'm not gonna lie. So let's see if this function actually works. We're gonna go to our FPS account, and instead of having all this ugly code here, we're gonna use print. We're gonna specify the same stuff as here for how to render it. And then we're gonna specify the format and the arguments for the print here. Delete all this nonsense. Cross our fingers. Not quite. Fill box. Now it suddenly doesn't like fill box. Why? 271. Yeah. I wonder why it didn't trigger those. Must have been something wrong. 275. Yeah. Yeah. Should have triggered up at all of these. So what happened? I don't remember, but I'm gonna fix it now. 283. Essentially the same error. 288. Since we changed the interface to indicate that we are manipulating the frame buffer, we now have to pass by pointer instead of by value, as we did before. So we have this. Now it says it works, but who knows? So we have FPS, but it's the same call as before, so it fooled me once. FPS in big letters should prove to everyone without a doubt that it's actually a new program. Yeah, fine. So now that's awesome. Now we can get rid of this comment, and now we can give us some information. So basically all I wanted to know is something like, hey, text, what's the text count? And what's the text cursor? And we want to see how this changes when we start manipulating our text. This C. Oh yeah, that looks good. And if we just type in things at the end of the buffer, both these values should stay the same. So hello world is the same. Now if I start deleting, all at the end of the buffer, both should go down. But I should increase the scale factor of this so that you can read it a little better. So we had a concept of zoom, so that we can blow out the resolution of our internal buffer onto the screen. I'm just gonna zoom twice so that you guys can better see what I'm doing. Yeah, that's better. Yeah, at least it's more readable. So we can also increase the initial size of the window so that I don't have to resize it every time. Where do I do that? Yeah, here. 2080 by 720, I don't know. I don't know what good values are. Yeah, that's good enough. Hello world. And now if we delete, both should go down the same way. And you already see that it didn't work. So the text count did not change. Only the cursor changed, even though we deleted something. So already found a bug. Isn't that amazing? Not the bug, but that we found it so quickly. What is this? Why do I have this? Oh yeah, this Visual Studio Console nonsense pops up. Okay. Easy. We just go into our remove function. Yeah. And as we see, we never changed the text count to reflect what we removed. We only decremented the cursor, but we also need to indicate that we also shrunk the text. So it's always nice to have some tools to guide you in debugging, and this time we basically use the same tools for rendering and for debugging, which is also nice. So hello world. Display is probably now. So now for another test where we type something, then we added something in the middle. New Year's world. And now we want to delete something. So if you delete just the end, everything works fine. But how about we delete the new? Yeah, I would say this works quite nicely. Yeah, a lot of little mistakes, but works well now. Also, what I wanted to do, just somebody said that the text line advancement here is too big, and I'm not sure that's actually the case, even though it looks like it. Like when I say something big, like I love it. It already works, man. Maybe I need some Y words. I cannot move up or down right now. Why? This is the smallest. Yeah, maybe. I mean, maybe it's a little bit too much, but I'm not sure. I'm doing great, Samuel. I'm fixing bugs. I'm implementing features. Everything is nice. Yeah, look, everything is still quite fast. Yeah, we have a little bit of debugging capabilities. Yeah, I'm quite happy with this so far. I cannot use, I cannot use Unicode characters like German letters, because we basically kept the code point space to be only ASCII chars, because we don't handle Unicode yet, so I cannot type in more fancy letters. I'm so sorry. But maybe in another tutorial. So next thing on the list, we fixed 2 things on the list. Next thing on the list. The list says implement basic memory arena. Maybe we do that. Why not? I mean, it's just a stepping stone for what we want to actually do, but hey. What's the the letters at the bottom is our font atlas that we generate from our font file. This is the texture. We also have a possibility to basically to print any texture, and we also have the possibility to print subregions of textures. All these texts, all these glyphs are actually in here, and we copy it from the buffer onto the screen. Yeah. implement basic memory arena. Sounds good to me. And since this is something that we might want to use all the time, I'm just going to add it to basic. So a memory arena, as I typically use it, looks just like this. It's just a giant buffer, but other than having our U8 array, which only indicates how long the data is, we also indicate how much of this data is actually in use. So same structure. Yeah. Used count, something like this. Then we want to create one of these. Maybe later. Maybe in our platform code. Do I have a platform code? I have platform code. So let's just say the platform code, we can ask it to generate an arena for us using its magic. And we have to specify, well, right now we don't have any struct reflecting some settings in our platform layer because our platform layer is very trivial and works without any additional information. So all we wanted to tell is how big this arena should be. And then all we do is essentially call our platform allocate function somewhere here. And we have an arena here. We can initialize it to 0 so that we do not forget to clear its setting if we later on add some more fields, maybe for debugging purposes. Do this. And then we do count. It's just whatever the byte count is that we specified. The used count is set to 0 because of this initialization, and then we just return our arena. Now that we have code to generate such a thing, we want some code to use it. And this is how I would do it. So basically, let's have a simple allocate byte functions. And you say, hey, I want bytes from this arena. I mean, this would be probably a good point to explain how this works with a sketch, but I really don't have anything set up properly to draw stuff other than in Paint. But let's just do that for a second. Just for the lols. So let's see. Let's say you have your memory arena, which is basically just a continuous chunk of memory. You get that from the operating system. It's quite big. And you have your base pointer. Yeah, let's just say it starts here. So base pointer. Wow, this is so little. You couldn't have chosen a smaller font size. So you have the base pointer, which indicates where the first byte of the arena is. I love Paint. So. And then essentially all we do is we have a marker which indicates how full the thing is, like so. And we say that everything in here, yeah, just gonna give it a little star. Here's. And this is just basically our used count. Oh, yeah. So, and this is this down here is basically our available count. Let's call it count. Yeah. And I shouldn't have changed the color. Man, you really gotta love this program. Anyway, so this is the whole count relative to the base, and this is the used count relative to the base. So if we allocate stuff, we basically add into here. So how it actually would look like is, oops. let's just look at how individual allocations would look on the memory arena. We would just ask it for some bytes here. Then we would ask it for another bytes, some other objects that's stored in the arena, and maybe another one here. Maybe some other ones here. And we would fill it up with some bytes, and all these bytes represent some form of data that only the person or the code that asks for these bytes knows how to interpret it. The arena does not care. Essentially just gives you space if it has any. And then you would basically see here is the use count again. And what another feature of the arena is that we actually can also pop things back. So let's say we do not need this last allocation here. We can just bump this up. Delete this and reset the use count to the previous state here, which we might not record, but I'll get to that in a second. Essentially, if we remove this, we can then repurpose this memory for another allocation. So if I was to copy the whole mess here and just say, hey, look, this stuff does not exist anymore, and move the thing back up. Wow, some awesome painting skills. Then essentially our use count would go back up so that we have more room available for further allocations. So essentially this means this works like a stack. So we can put things on top of it and we can remove things, but only in order. So you cannot, for instance, you cannot get rid of this first allocation before you got rid of all the previous allocations. Because if you do so, the use count would reset to the top, and further allocations would override regions that you already allocated for other purposes, and they would wonder why you end up overwriting data. So, but that's the basic scheme that we want to implement. I hope this was somehow helpful to visualize. It's essentially just a stack. And all we need to do is we say, hey, I want some bytes. But we can also be a little bit, we can be a little, optimized. I don't know, probably not really anymore, but we can also specify some alignment that we want for the data. Maybe you're using SIMD instructions and they require to be 256 byte aligned or something. You can specify it here, byte count, or align and byte count. And all we do is, first of all, there's two ways you can handle it. You can basically can assert whether or not we have enough room for this allocation to happen, and then your program might crash. Or you want to be more flexible and allow the allocation to fail, but then you would have to add a lot of error handling code in your code base, which I personally don't like, because all I really want to do at that point, if I notice that I don't have enough room, is basically to increase the initial memory I gave to the allocator, because my application, for instance, in a game, it has a more or less fixed memory budget that it allows for, and if you cannot meet that, then it doesn't matter when it fails. If it fails at the beginning of the game, where you ask for all the memory of the game and it crashes, then you can tell the user, sorry, but you don't have enough RAM to run this game. I'm very sorry, this is out of spec. But if it happens, it can happen anytime in your system. You basically have to catch all these little arrows. Every time you want to do a smaller allocation, you have to check whether or not it actually succeeded and handle that. We're not going to do any of that. We're just going to say, hey, you know what? Assuming wherever I am right now, maybe I call it arena. Wherever the next free byte is, which is basically arena base plus arena use count, it tells you this is the first free byte available. We remember that, and then we want to see whether or not it is properly aligned. Aligned means essentially that am I going to get into an alignment? I'm going to use it and not completely explain it, but essentially just a requirement. This tells you that the address that you have for your allocation needs to be a multiple of this byte alignment count. For instance, floating points are 4-byte aligned. So typically, if you would store a floating point in memory, the last 2 bits of the floating point address would be 0. And the chars, on the other hand, or unsigned 8s, are 1-byte aligned because you can place them in any address. And structs like this are a little bit bigger, and they might have different alignment requirements. And all we want to do is make sure that the space here, the pointer, is essentially just an integer value, that this integer value is a multiple of aligned byte count. In order to do so, you can just take the pointer, add alignment byte count -1 to it, and then what's it? Yeah, and then we just basically I'm gonna call this alignment mask. Just the value -1. So if you look at the float case, for instance, so we have our float address in bytes. Just say it looks like this. We have some bits here, and the last couple bits needs to be 0, 0, because our alignment is 4, and 0, 0 means that it's a multiple. This value is a multiple of 4 because we can bit shift it by. So these are bits, by the way. So every one is a 0 or 1, not hexadecimal value. Basically, it just means that we could shift down by 2, which in other words means we can divide by 4 without losing any information. Like you can shift down by 2 and then shift up back by 2, and you will end up at the same location. You do not lose any precision in doing so. But as you notice, this value here, these 2 bits, are a 3, but our alignment requirement is 4. So the mask that we have here is 1, 1, which is whatever the alignment is -1. So that's what our mask represents here. You take whatever the alignment is and subtract 1 from it. This also assumes that that our alignment byte count is a power of 2. Because this subtracting a power of 2 will lead all the like, for instance, you have something like 1, 0, 0, 0. If you subtract that, you would get 0, 1, 1, 1. If you have something like 1, 0, you get 0, 1. If you have something like 1, 0, 0, 0, 0, and you subtract 1 from it, you get 1, 2, 3, 4, 5. You get this. So you end up with a mask that is populated by 1s at the lower bits, and this way we can ensure and check that the lower bits of our address are basically cleared. And in order to do so, we first add the mask to our base, essentially trying to round it up to the next value, without flipping the this most significant bit for the address. So we if we add our alignment mask to our base, we get to the next higher to the next basically we want to round it up, but then we want to clear all the bits that are in the alignment mask. So like so. And then we get a base. Maybe we need an example. So let's say we have this alignment of 3, like in this case, and we have some kind of value here, like 1, 0, 1, 1, 0, 1, 1. And then we have a value that is properly aligned, for instance. this is properly aligned, and then we add our alignment mask to it, which will lead into this being like so. And then we AND it with the negative of the alignment mask, which is basically, in our case, and this being flipped. So what is this? 0, 0. How many bits are these anyway? 1, 2, 3. Man. So let's just say these 8. So that's 8. 6. Yeah. 1, 2, 3, 4, 5, 6. So we have the negative mask of our alignment mask would be the significant bits would be 1, and the unaligned bits would be 0. So if we mask this, we will end up with the last bits cleared, and it would be the same address because this address was already properly aligned, right? If it wasn't properly aligned, let's say it's 1, 0, yeah, at the end, then adding 1, 1 to it would basically, this was 1, this is a 0, this is a 0, this is a 0, this is a 1. It would flip to the next address like so, I think. Maybe I messed it up. And then if we clear it out like so, we will end up with this address instead. So as you can see, this address was rounded up to the next valid aligned address. This is essentially what this function does. So, and then we have the proper base, and now we have a valid base, and now we want to see whether or not we actually have, starting from this base address, if we have enough bytes to serve to our user. So if we say something like if base plus byte count is less, so we just assert it because we're not going to handle this error. We just want to make sure that this never happens. We just want to say if base plus byte count is less than the end of the available memory that we have, plus arena count. So yeah, we want to just make sure that however much we allocate, it never exceeds this boundary down here, like so. And if that's the case, then everything is fine, and all we do is just return base, and all we do is advance our arena used count is just whatever this last address is relative to our base. So like so. Basically, we allocated something. Let's say we allocated this blue chunk here. Our base was here. Then we returned that base, but we also added some data. So our new base that we can give should be here. So we take base plus how many bytes we have and subtract it from this base to know how much the use count is. So hope that makes sense. And then we can return it. And this is aligned. But typically, you probably do not care to use this function directly. So we will give you a more handy function to just say, hey, give me some data of a specific type with enough space of a specific type. So we just say something like, okay, we use a macro. The reason why we use a macro, you'll see in a second. We just say allocate item, for instance. And then we supply the arena. By the way, you can ask me about this at the end of the stream if you are curious, or if I explained that very poorly, so that we can go over it again. So we say basically just which arena we want to use and what type we want. And all we do is essentially we just call this allocate bytes function. We use the same arena, and the byte count is basically just whatever the size of the type is, and the alignment count is something that we can get by calling the function align of type. So this is a more modern C++ feature, like C++11 or so, I think. So if you can look this up, and it will tell you the alignment of a specific type. Yes, C++11 as it says there. and you just say something, not align off. Is it align off? Returns the alignment. Yeah, exactly. So yeah, this was really dumb. So I just want the alignment. So as you can see, the line off of char gives you 1, a line off of a pointer gives you 8 on a 64-bit system. And a line of foo will give you whatever foo's biggest field's alignment is. I'm not going to go over alignment rules, but just so you know, we're going to use this operator so that we don't have to think about it. And the other thing we want to do is basically, because this returns just an unsigned 8-bit pointer, but the user kind of expects a certain type, we can cast it to the pointer type, to the type, like so. And the reason why I add some more parentheses around this is because this way, because this is just a macro, and things in macros can be, because it's just copy pasted, it might end up that you kind of mess up the rules of the syntax precedence. So in order to make sure that somebody who calls this function can do with it whatever you would do when calling a function, when he used this macro, we add parentheses around it to make sure that this is evaluated as a closed thing before any other syntax is added in front or behind it, basically. So, and now we want to use this thing and just see if it works at all. Maybe, but first of all, I want to compile it, see if we have made some small errors. Error 75 says, yeah, so basically we cannot do this operations on a pointer type. So I will cast the base into a usize type to do all these operations on it. And after that, we can cast it back to U8. Another dumb quirk of C++. And then we have a, this basically just complains because our allocation mask, alignment mask is not 64-bit, even though the rest of the computation is 64-bit, and that might result in different values. Maybe they just cast it and then they add zeros instead of adding all ones into the mask, and we want to make sure that it's all ones except the it's all zeros except the last portions are ones. Area doesn't know what an area is. Fair enough. An arena. Then we have on the same line, it says exit identifier not found. Oh, because no, assert is here. Can I not use assert in here because this one uses the exit, and the exit is defined in standard in or something. Now we get into C++ ordering shenanigans, which is one of my favorites. So essentially, this code just works because in our main function, we use stdio before we do anything else. But now our assert requires it, so we need to place it into basic. You could have a different way to handle assertions, so it might not require you to include stdio. But since we're using it anyway, we can just... Why? What? Are you kidding me? Where is it? Is it here somewhere? Windows Edge? No. Print? No. Okay, let's just look it up where exit is. Exit C++. Where is it defined and how it's defined, and then use whatever that is. Oh, it's stdlib instead of stdio. Yeah, well, we can deal with that. Let's see. Now we will complain because we don't know what stdio is. That's fine, but we don't need it here. We can put it here. Just because we use printf temporarily, even though we have our own way to print stuff to the screen now. It might be still convenient if that fails to print to the console. And platform 87 says doesn't know what byte count is because I misspelled it here. Oh, yeah, that's good. Now we go into main, and there we had some. We already did a big allocation for our frame buffer. We did it like this. We said make frame buffer, and then we allocated this giant portion of it. And if you look at our render code, make frame buffer calls platform allocate bytes. We can replace that and just say, hey, we have a memory arena now. Use that. All our memory comes from the same spot. Like so. And then you, instead of saying, hey, give me that, we say allocate. Oh yeah, another thing. Almost got you. So instead of saying allocate item, we can also say allocate items and specify a count. And tell it to allocate a bigger array. And this way we just have to say whatever the size of is times the count. The alignment of one type and an array of this type is the same, but we just allocate count many bytes of type. And then we can just reuse this call and use allocate item, leave the count, and just call the allocate items macro with a 1 instead. So, like so. And then we go back into our render code and say allocate items. And our items are essentially RGB8s. We specify our arena. I just call it memory here. And then we have to specify how many items we want, and it's just width times height. And this should work then, but we'll see. First we need to, 128. Font, the font is complete. Page says, no operator found, which takes right hand size int. What are you talking about, man? Oh yeah, because this C++ is so dumb. Because it basically says this is an unknown function, so it assumes it returns int, and then it says font atlas must be int because I used auto, but it's not correct. One of those cryptic errors that beginners potentially have a lot of problems with. Which, yeah, it's just bad. So we specify an arena instead. Don't have some. Previously, this code was doing some arbitrary memory allocation, but now we can basically use this arena and prevent it from ever allocating actual memory. So first, a message from our sponsors. Oh. We're just gonna fix this stuff first, and then we're gonna, yeah. Right now we still don't have a memory arena, so we're gonna call our platform call to generate one that's good enough for our purposes. Just gonna call it memory and say platform allocate, or was it just platform memory arena? And just give it a big size, like it's like 1 megabyte. It's not a lot. Just gonna say 10 megabytes maybe. Still not a lot, but we'll see. Maybe if it crashes, we know we have specified too few. And this one also, our test buffer, which we just basically just filled in the random rectangle, if you can recall. This one here, just a texture we generated for testing purposes to see whether or not it would copy properly. This one also now requires some memory, and previously it also just did its own memory allocation in the back, which is something that we don't want. Oops. So how far are we? We're in second hour. Check first error, please. What error? So, and now our make font also requires an arena. And yeah, we're gonna use that. Everything seems fine now. Does the program still work? No. It indicated that one of our allocations is basically too big. Well, we can debug it with Visual Studio and see when it actually fails and why it thinks it's too big. So width times height. So essentially, our big back frame buffer is just too big for our arena, and we can do a little calculation and see if that actually makes sense. Oh my god, what the hell? So it's 224 squared times 4 byte each, and this divided by in kilobytes divided by 24 in megabytes is 16 megabytes, and we only specified like 10. Makes sense to me. So let's just say it's 200 megabytes. Whatever. Not a lot. Never mind now, okay. Way ahead of you. Okay, everything works fine. We have a memory arena. Our program never touches memory, but it also didn't do that other than from the beginning. Yeah. Memory usage is 10 megabytes right now, so we asked for 100, but we actually only need 10. And the other nice thing is what we can do right now is essentially, yeah, how about that? Since we're at it, and I just wanted to show you why memory arenas are awesome. You might want to have something like if we're in debug, we want some extra fields to our arena, like a max used count, to know just how much we actually ever needed. And in our case, all we have to do is whenever we change, whenever we increment the use count, we just say max use count is whatever it is plus whatever the maximum is from the maximum and from the current use count. Like so. Let's just first see if that compiles. Max, and then define, yeah. You don't know what max is? Okay, how about I implement it for you? Why not? Yeah. Maybe I use the 64-bit method because whatever. I'm just gonna say if a and while we're at it, we're gonna do the minimum one too. And it's always nice that it works basically in reverse to. Oh, it's dumb. If A is bigger than B, we return A. Like so, I think. Yeah. So minimum will return the first one. Maximum will returns the second one if they're equal. Maybe. Not sure. So, and then I'm gonna use, and then I'm gonna call it maximum. Oop. So, okay. And now what we can do is basically in our main function, when we're done here, as if we have our thing and we close it properly, we print hello world, arrow, stretch bits. Oh yeah, now it has an error and fails. Oh, now this is this one because if we are done, we should not be rendering anything. So essentially, I have some function somewhere that indicates whether or not the platform code is actually done. So if we're here, no, that's the frame. Essentially, after here, if not do continue, we can just break, because otherwise the rest of the code will fail because we remove the window or anything. And now it should print our still this error. If not to continue break, continuous false. Why? I compile probably. That's curious. Let's see. Let's see what happens. If we quit, we should be here. Let's see. I close. I just close. It doesn't affect the message. Oh my god. Why does it close it if it doesn't affect the message? That's curious. Do I do this somewhere else? Yeah, a little detour. We have a callback, and if the window gets destroyed, we want to quit the we want to post the quit message so that our application knows that we're done. So why is that not working? Include Windows.h. They're equal. What do you mean? They're equal. Yeah, maybe a little late the message. No. To continue. This should just break. I don't get it. Why are you not getting in here? So let's get to the platform code and see. Because I should have said. Oh yeah. See, I'm an idiot. I never set our window callback. Why ever that ever worked is beyond me. But let's see. Basically, in our platform code, we have created this function, but we never used it. So it should be here. I wonder why. I thought maybe I copied a different state. So let's see. Yeah, now it works. Okay, everything's fine. Now we print we are done here. So whether we stop the application by pressing the X button or by pressing Alt F4, yeah, it should shut down properly so that we can actually react to it. And right down here, we can react to it, and we're just going to say printf memory max used byte count %, and just use our memory arena max byte count. But remember, this information is only available to us if we're on debug, so we need to guard it. Was it if debug or if defined debug? I always forget. We'll see in a second. Yeah. What? %LLU. Not enough arguments. There's one argument. What else do you want? Memory. Isn't it called memory? Oh yeah, it's called just memory used count. I get confused. So now it prints how big it actually was at the end, which is also nice to ensure how much memory usage your application actually needs. Minimum, maximum? Did I mess that up? Did I spell that wrong? Am I stupid? Yeah, I'm stupid, but oh my god. Maximum. Is this bad? Come on, tell me. What are you talking about? Thrall, so you're trolling me, right? No? Anyway, so this is a nice and easy way to figure out the memory usage of your application, especially in a scheme where you kind of have very few, where you kind of have a limited set of these arenas. You can look how much you actually need, and yeah, the less the better, and the more stable your application is if you can just guarantee that you have a very tight memory budget. But we're not quite done. I recall that we have the platform read entire file thing actually allocates memory that we never release. So we need to fix that function. So read entire file right now essentially just allocates with virtual alloc, but we can now specify an arena for it. Because why not? This way we have more control. So we say, give me memory. We want some U8s. I mean, I can just call allocate bytes, I guess. And say byte count many, and they're aligned by 1. And then you get a, yeah, that should be enough for this. Let's just see where, if we have some other allocation. Where. So this looks good. In our main. Now, main, we don't have any allocations in our font. Yeah, we have this, which, oh yeah, the glyphs are still allocated using the platform code, which is something that we don't want. And do I ever use this all the time? Glyph buffer, do I use this? Do I need this forever? Oh no, this is just for intermediate loading of the glyphs. So here we can also just say, hey, give me some memory, man. Give me some memory. Yeah, it's just bytes. It's just bits. Yeah, just bytes. Basically, it's just alpha values. I'm just gonna say, give me some bytes. This is just temporary, and we want however many glyph counts we have. And this is temporary, so at the end of the day, we want to release it again. Same goes for the file data. After we read the file and process everything that we need, we want to get rid of it. So at this point, we specify our memory arena. But note that all the allocation that we want to preserve are happening at the beginning here. And all these allocations are temporary, so we can get rid of them at the end of the file. I already annotated this, so at the end, before we return, we would like to call something like free bytes, use our arena, and then specify in reverse order of our allocations, we want to specify what we want to free. And the other thing that we allocated is basically the file data. And we don't have a free bytes method yet. I mean function, excusez-moi. No, it's just free bytes. Leave them bytes. Yeah. And all we need to tell it is basically the base that allocate bytes returned us. That's what we want to free. And all we want to make sure is that the base is actually inside our allocated region. So all we want to do is say, hey, is base actually smaller than our base plus our use count? we go back to the graphic, essentially we want to make sure that if somebody gives us a base to delete, so free, it should be inside this allocated region. If the base is outside the region, we know that the user messed up. But if it's anywhere in here, we don't properly check whether or not it is allowed to free the previous item, which is just a very basic implementation. But if it's anywhere below this mark, like here, for instance, we say it's a valid base to free and just set our used count to the point. Basically, that's one thing. Also, we want to make sure that the base is actually part of the arena. So we want to say that our arena is less equal to the base value, so that it could happen that somebody specifies as a base, which even comes before our arena base, which means it's completely out of bounds of our arena. And we want to catch that error too. It might happen, for instance, if you have multiple arenas, you might get confused, and it's nice to crash and tell the user, dude, you're doing it wrong, man. This is bad. So we do something like this, and all we do is just like here, we just say, hey, the used count is whatever the base is without the byte count. Essentially, we say, hey, let's say, for instance, we specified this base to free, then we just say, what is the distance from this base to our base, and that's how we set our used byte count then, without any other checks. It's just, this is the simplest, dumbest thing, but it will catch if you, by accident, mess up the order or anything. So 164, great game. Allocate bytes, that's bytes. Yeah, let's see. Yeah, everything loaded fine. And our memory usage should be a little bit smaller than before, because now we actually freed, oh no, because basically we used it once and then freed it, but still the total is the 10 megabytes that we used. Yeah, but we can repurpose it now, so that's also nice. Okay, cool. Wow, so this went quite well so far. So fat? No, so far. So, okay, cool. Everything is fine. We render it. Why is our frame rate high? Oh yeah, because we have shrunk our resolution, so we have less things to copy. Okay, cool. Next thing on the list is basic memory. Work on simple undo redo. Well, I don't think we're gonna make it, but we set up everything so far. So let's see what else we could do. Maybe this is something we do another day. Check line space, multi-window support. Do I want to do that right now? Doubt it. Maybe it was just started in the draft and I stop after half an hour. That's fine. Okay, let's just have a new file, because I'm just gonna call it edit.h. It's gonna depend on our basic. Gonna be pragma once. Pragma once. Then we have some kind of buffer which indicates our undo redo stack. Yeah, I don't know. I call it edit history, maybe. And I'm not quite sure how it's going to work, but I'm gonna do a fixed undo redo so that we don't have unlimited undo redo. And essentially, at some point, we just cannot roll back. Okay. So we might want to have some memory for this. This called this buffer, and then we want to have some data on top of that indicates changes basically. And I'm not quite sure how to do that, but let's just think about the most basic thing. Basically, What we want to do is record a change, for instance, like record insert, maybe. And if you look at, if you look at how our wrong file. If you look at how our insertion code works, the information that it has is like this. So it has a text file, cursor, max count, and a character that we want to insert. So right now we can only insert individual characters. So all the information we need essentially is basically, why do I have a max count? Oh yeah, the max count is how big the buffer is. The information right now we only need is where it was inserted and what was inserted. So we're just gonna do that for now. So and see, we can update it later, but essentially we need some entry that represents this information. And the best way to do so is, I would say, some form of I'm just gonna make some tag union that tells us whether or not we insert or remove something. So just see that. We have added history entry or record. Doesn't really matter. Then we have bool is insert, or because that's the default, we say bool is remove. And all we want to know is specific to whether or not it is a remove or an insert. Insert has cursor and a U8 character. Text cursor. Well, in this context, is everything is text cursor. Yeah. I completely alienated the chat, it seems, with my with my responses. But anyway, so well, I could actually just basically have fixed size of these for now. I'm not sure. Let's just say it's one. That's not a lot, but let's just bear with me. Just do this, and essentially right now we just want to add this. And what we do is typically, first of all, we want to make sure that for now, since we do not support some kind of ring buffer or rolling buffer, we just want to make sure that we have enough room to insert this new entry. Is less than C array count was our macro for fixed size static arrays. And then all we do is take the next record. Oh, also this is part of history. Internet is finally back. Hi, MTX set. You missed almost all the stream, but that's fine. We just did a little bit of cleanup. We fixed our deletion code, and now I'm working on a very simple draft on how the undo redo might work in the end. Welcome. Happy New Year. I clear the record. I set the insert union field to our parameters. And that's it. That's our insert. And now we want to kind of use this. So since this is a big struct, I'm just going to go into main. First of all, in main, I want to include our new file, edit.h. And at the beginning, after we constructed our memory arena and stuff before we enter the frame, just gonna have our history, and because it might be quite big at this point, I'm gonna just allocate it with our memory arena so that it doesn't blow up the stack. And I'm gonna clear it. So, and now whenever we do an insert, we also want to add entries to our history. Maybe like so. So we have this call. Right now it right now it just manipulates text, but right now we might want to just prevent the user from having to call two things. So we're just gonna call a new version instead. I'm just gonna copy this, just go to our edit. Oops. Oh, so. And we're just gonna use our edit history here. And maybe it's a good idea to also save the text in the edit history, but maybe not. I'm just gonna keep it more or less flexible like so. And now we're gonna, so yeah, maybe I also take these functions here, which are part of the insertion stuff. Now they are part of the edit. So don't know where to place it. Just gonna put it in here. So, and then we can just call this function here and call our record function at the same time, so that the user does not have to sync it up by himself. Instead, we provide this we provide this feature for them. All he has to do is basically pass in a new parameter, which sounds like a fair deal to me. So something like this. And now we need to everywhere where we have an insert, we also want to provide our history now. So it's all the cases. So not a lot happened. See if our functionality is preserved. Das System kann okay. So far this still works. If you could spell properly. But eventually, since we only ever add new entries and never remove them or do anything with them, our buffer will eventually run out of space and for new entries, and we should be crashing. So that we can see, this is real testing. Oh yeah, I need to repeat. Yeah, it takes a while. I'm just gonna cheat a little bit and make the buffer a little smaller so that we can actually see that this triggers, just to see whether or not anything that we type so far makes any sense. Trigger right now. Yeah, okay, perfect. So that works. Okay, cool. Now we have this history, and we want to be able to undo it with some kind of shortcut. So let's just first undo the insert and see how that works. So text manipulation is here. Now we have a undo. We have our history. And we get a text and a text cursor. Maybe you also get a max count because we don't we haven't specified it properly. Now, how would that look like? First of all, if we have no records, there's nothing to undo. So we can just return early out. And now we want to assert. We get our record first. Auto record is we get the topmost record, basically the last entry, because that's the next thing that's on the thing that's the last change that was done, and we need to reset it. Wow, cannot speak. Isn't that great? So and we just copy it because it's not a lot of information, and we want to assert right now, because we don't support the other one, that this is not delete or is not remove. So we just assume it's insert. And in order to undo an insert, we have to do the opposite of that, which is a remove. So we know that it was inserted at text at cursor location cursor, and we want to delete that. So basically, we will call the remove function here. In order to call that, should be available. Before we do the history stuff. Yeah, it's a little bit hand wavy managing of these functions, but you can organize it however you like. I personally don't care. I like it if all the things are in one file that are concerned with the same thing. But I needed to make sure that the remove function was defined before undo, because we want to call it. So that's why I moved it up in the file. All I want to do is basically, hey, let's see. Let's say we want to remove a text, and the position is the cursor, because we want to remove in front of the cursor. So it needs to be cursor -1, right? Oh, I insert at 0. For instance, I inserted 0. Then I want to remove at 0 also. So it needs to be the same thing, but our remove essentially assumes that the thing that we delete is in front of the cursor. So it needs to be cursor +1. Yeah. And then we tell how much we want to remove. This is always 1. Yeah, that's the whole undo so far. And of course, we need to decrement the record count, so that we wouldn't be undoing the same record every time. So now let's first see if this compiles, if I didn't do any. Oh no, your GF distracted you. Should I repeat the whole stream again for you? Man, some people would love to have your problems. Insert. Yeah, I mean, the girls are us people probably won't refund 2 girlfriends 2 days in a row. It's never gonna happen. So we set the text cursor to this because the remove expects the text cursor to be updated. So we set the text cursor to where it would have been before the after the insertion, so that that remove can update it. It probably stop lying, huh? Yeah, I mean, Cake's girlfriend and him are never in the same room at the same time, or are they? So this compiles. Now get to the main, and now we add our first command, basically. We have some command codes, and I can just, do I recognize whether or not we hold down Shift or anything? I don't think so, but let's check it out. We have push char is character. That's all we have. So later on, we might want to check whether or not Shift is held down or something, but we can do that. Yeah, we will just use some not key character basically to do the undo, just for now, because I'm lazy. So just gonna say case vk. I don't know. Yeah, what's a convenient character? Maybe something like F7, because on my keyboard it has the go to the previous track icon. Why not? It's a very common thing to use undo with. So we just call undo on the history, then provide the text and the text cursor, because that's what we want to update. And it's never going to work. Also, we want to provide however big the text can actually be, even though we don't use it. What? System kann den angegebenen Pfad nicht finden. What are you complaining about, bro? Okay, let's just say hello, and then I hit F7 multiple times. Wow, look at this, people. I have insert undo. It's crazy. What else could you actually want? Of course, it gets broken if I say hello world, and it would still work if I insert something in the middle, I think. Let's just try that out. So I move the cursor, which basically does not change the file, but just the cursor. So this should also work. And then I hit F7 and should just delete the new. Yeah, I think that works very well. The problem is, if we ever delete something like so, and then we try to undo, it will crash because we do not record the deletes right now. Bam, it crashed. Okay, but that was quite, yeah, that worked quite well so far. And yeah, let's do the undo for the okay, let's do the undo for the remove, maybe at least draft it. So because that was actually quite easy, let's try to record a remove. And if you recall, the interface for remove looks like this. We just tell it the cursor and how much we want to remove. So our remove is already more flexible than our insert. But here comes a problem. Problem incoming. Yeah. I mean, I can hack it. I'm gonna hack it. I'm gonna translate it into multiple removes. Or I'm just gonna assert for now that it's 1. I'm gonna assert for now that it's 1. So essentially, we just say how much we wanted to remove in the remove. Record remove is just cursor and remove count. But the other thing is that it also needs to know what was removed. So it also needs to have the text, because we want to, if we delete it and we want to undo the delete, we need to remember what was deleted to reinsert it. Not enough information to just remember where it was deleted, because we want to reverse this change. So I'm gonna also give in the text, then the text cursor, and then the remove count. So I'm gonna add a new entry. I'm gonna say this time it is a remove, is remove to true. And then we have a remove portion here, which I haven't done yet, but it would pretty much look the same way right now. We say where and what was removed. It's the same thing, but we will unify it as we go along, basically. I just want to keep our options open for things that are different, and we'll see from there. It's always easier to unify stuff after you explicitly handed all the cases first. So we say move, we say cursor, and the character that we get is basically text base cursor, because we remove in front of the cursor, it should be cursor -1, right? So I'm gonna assert that cursor -1 or minus remove count. Right now we're just gonna assert that remove count is 1 because we haven't implemented the other case, like so. We assert that cursor minus remove count is actually not minus, because both of them are unsigned. We want to make sure that our remove count is less or equal to cursor so that we can safely subtract it from cursor. And we say our character is whatever is in front of the cursor. That's the thing that we want to remove. Cool. Okay, cool. And now, instead of asserting on undo that it is a remove, we will actually check if it is a remove, since we now want to support both of these. Yeah, that's the same. And now we have to call insert instead. And insert looks like this. Call insert. We have the same text. Sorry guys if I scream sometimes. My microphone is not set up very properly. The character that we want to insert is stored in the record in the remove field. And the text cursor is, of where we want to insert it is basically we stored exactly where it was removed. And just like here, we have to basically set the cursor to where we would want to insert it. So after the remove, the cursor has moved to the left. So we need to insert it to record.remove.cursor -1. And we want to make sure that this is actually greater than 0. And then we can pass in the cursor. And this should do the undo. Wish me luck. Final stretch, we're almost done. Hello world. So if I delete it now and then undo the delete, it crashes. Exactly what we wanted, right? Not quite. So let's see. Oh yeah, we never record the removes because I haven't called this code yet. So just like with with the insert, where we have a version where we also use the history, we want to have a remove with the version where we call the history, so that the user can conveniently just call the same function essentially, but with the history to record the change. So just like with the insert, we just say, hey, record or remove, please. Then do the remove. And then do the actual remove you would have done just on the text without the history. Like so. And now we need to actually use this function in our main. We can look up where we ever use remove, just in this place. And now we only have to pass in our history too. So, I mean, the bad thing is that the user now has to be aware that they always call the appropriate function with the history, but that's not something that you can easily get rid of if you combine history text and text cursor into a more convenient struct for the user to pass around. In our case, we are the dev and we are the user, and we want to make our lives easy. Hello world. Then we delete, and then we want to undo the delete. Hey, and now we want to undo the insert of the world. So I keep on pressing F7. Man, if that is not success, if this does not look like success to you, then I don't know what, people.